Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of PG Mustard, and I'm joined as usual by Nick, founder of Postgres AI. Hey, Nick.
Hi, Michael, and let's welcome our guest.
Yeah, we are joined by a very special guest, Sugu, who is a co-creator of Vitess, co-founded PlanetScale, and is now at Supabase working on an exciting project called Multigres. So welcome, Sugu.
Thank you. Glad to be here.
All right, it's our pleasure. So it's my job to ask you a couple of the easy questions to start off. So what is Multigres and why are you working on it?
Multigres is a Vitess adaptation for Postgres. It's been on my mind for a long time, many years. And we've even had a few false starts with this project. And I guess there is a timing for everything. And finally, the timing has come. So I'm very excited to get started on this finally.
Yeah, timing is an interesting one. It feels like for many years I was looking at PlanetScale and Vitess specifically very jealously, thinking you can promise the world, you can promise this, horizontal scaling with a relational database for OLTP, and it's all of the things that people want. And we didn't really have a good answer for it in Postgres. But all of a sudden, in the last few months, it seems almost, there are now 3, 4 competing projects all doing it. So why now? Why is it all happening now?
I would say I think there is a timing for every new idea to gather momentum. Like the idea may be good, but the timing may be bad for one reason or another. But once the timing is good, then it is obvious that it is the right time. And it feels like now is that time. Like I would say, for example, PayPal, there have been previous attempts at moving money online, but it never worked. But PayPal just came at the right time and therefore took off during that time. There are many such examples where some ideas came too early and didn't take off. But for Postgres, this feels like it's the right time.
That's interesting. Let me reveal something. We met in 2018, I think, at Percona conference, and in 2019 we met again in Nutanix at a meetup.
Nutanix, yes.
Go meetup, right? And discussions about Vitess for Postgres started, and a couple of times we had a call. I tried to involve a couple of guys and from my understanding, it never worked because you could not do it yourself, being busy with other things, I guess MySQL related, and guys looking at the complexity, other guys looking at the complexity, evaluated and didn't proceed. And actually, in one case, they decided to build from scratch. It was SPQR project. It's still alive, and there is sharding for Postgres.
Yeah, Andrew Borod.
Andrew Borodin. Andrei Borodin.
Yes.
Yeah, so and other folks also involved, and so for me it was disappointing that it doesn't work. And at some point I saw the message in Vitess, I think, that we are not going to do it. So don't expect.
I feel so bad because I was so excited about doing it, and then I realized, oh my God,
Yeah.
That's,
but now you started, and last week PlanetScale decided to support Postgres. So what's happening? I don't understand. Just right time, right?
Yeah,
enough number of companies using Postgres which really need it.
At least one horse will win.
Yeah. So yeah, it's great, but yeah, long story to this point.
Yeah, sometimes when there are multiple projects, there's kind of slight differences in philosophy or approach or trade-offs, willing to trade one thing off in relation to another. And I saw your plan. I really liked that you mentioned building incrementally. So Vitess is a huge project, lots and lots of features. But I've heard you talk in the past about building it quite incrementally while at YouTube. It didn't start off as complex as it is now, obviously, and you did it kind of one feature at a time. And it sounds like that's the plan again with Multigres.
Yes.
Is that different to some of the other projects, or what do you see as your philosophy and how it might differ slightly to some of the others?
I think my philosophy is that I would say I don't want to compromise on what the final project is going to look like. So any path that deviates me from hitting the target on the final project, I do not want to take. But any shortcuts that can get us early results, that we can do, but only those that ensure that it doesn't risk what we become eventually, which is a project that should feel native, as if it was for Postgres by Postgres kind of thing. I want it to be a pure Postgres project.
In this case, I must ask. In this case, are you sure you're still good with choice of Go language? Because sometimes we see projects which have really like sub-millisecond latency on average, like 100 microseconds, for example, on average. And Go definitely will bring a few hundred microseconds of latency overhead. So usually it's not a big deal, but maybe in some cases it's some deal, right? Are you happy with Go?
Yeah. I mean,
because you were one of the first big Go language users building Vitess, as we know from various interviews and so on. Yeah. So
correct.
Is it still good choice? Because now there is a Rust, right?
Yes, I would say. By the way, when we started Go. Compared to where Go is today, it was a nightmare.
Yeah, like 10 milliseconds, right? Latency.
Like 10 milliseconds or something round trip is what we were paying for. Those days we had hard disks, by the way, so that's another 3 to 5 milliseconds just within the database. But things are a lot better now, and at this point, the way I would put it is like the trade-offs are in favor of Go. Let's put it that way. Mainly because there is a huge amount of existing code that you can just lift and port. And rewriting all of that in Rust is going to just delay us. And at least in Vitess, it has proven itself to scale for, like hundreds of terabytes. And the latencies that people see they are not affected by a couple of hundred microseconds. So I think and plus there's this inherent acceptance of this network latency for storage and stuff. And if you bring the storage local, then this actually wins out over anything that's out there.
This is exactly what I wanted to mention. Yeah, I see PlanScale right now, they came out with Postgres support, but no Vitess, and I'm very curious how much it will take for them to bring it and compete with you. It's another interesting question. But if they, from past week, I see my main impression is main stake is on local storage. And this is great because local storage for Postgres, we use it in some places where we struggle with EBS volumes and so on, but it's considered not standard, not safe, blah blah blah. And so there are companies who use it. I know, I know myself, right? And it's great. Today, for example, Patroni, and since Postgres 12, we don't need to restart nodes when we have failover. So if we lose node, forget about node, we just fail over and so on, and with local storage, not a big deal. But now I expect with your plans to bring local storage, it will become more, I expect it will be more and more popular, and that's great. So you shave off latency there, and keep Go, which brings 200.
Good compromise. Effectively, it's a win because one network hop completely eliminates language level overheads.
Sounds good. Yeah, maybe Go will improve additionally, but yeah, good.
I wanted to go back, Sugu. You mentioned not wanting to compromise on feeling Postgres native, and that feels to me like a really big statement coming from Vitess being very MySQL specific. Saying you want to be Postgres native feels like it adds a lot of work to the project, or it feels like a lot to me. What does it mean? Is that about compatibility with the protocol? What does it mean to be Postgres native?
There's two answers. One is, why do we still think we can bring Vitess if it was built for MySQL, and how do you make it Postgres-Native? That's because of Vitess's history. For the longest time, Vitess was built not to be tied to MySQL. It was built to be a generic SQL 92 compliant database. That was actually our restriction for a very long time, until the MySQL community said, you need us to, you need to support all these MySQL features, otherwise we won't move
CTEs, right? Common table expressions with, right?
Yeah.
I guess it's SQL 99 feature, not 92.
Yeah, I think the first parser I built was SQL 92, which is the most popular one that I know of. So that's answer one. Answer two is more with the behavior of Postgres. What we want is completely mimic the Postgres behavior right from the beginning. Basically, in other words, we plan to actually copy or translate what we can from the Postgres engine itself, where that behavior is very specific to Postgres. And the goal is not compatibility just at the communication layer, but even internally, possibly even recreating bugs at the risk of recreating bugs.
In this case, it's very so there is Cytos. In the hands of Microsoft, it got everything open sourced. So before resharding was only in paid version, now it's in free version, open source. So it's fully open source, and they put Postgres in between. So they don't need to mimic it; they can use it, right? And latency overhead is surprisingly low. We checked it. Well, it's C, but it's whole database in between. But it's sub-millisecond, so it's acceptable as well. I think it's half millisecond or so in our experiments with simple select one or something. Select, just like. So, don't you think it's quite in comparison, it's quite a challenging point when you say I'm going to mimic a lot of stuff, but they just use Postgres in between.
Yeah. I think there's a difference in architecture between our approach between Multigres versus Cytos. I think the main difference is it's a single coordinator for Cytos, and there is some bottleneck issue with that. If you scale to extremely large workloads, like that goes into millions of QPS, hundreds of terabytes. So having that single bottleneck, I think, would be a problem in the future. Whereas,
as I understand, you can put multiple, you can have multiple of nodes there, and also you can put a page bouncer to mitigate the connection issues, so it can scale as well.
That's good. That's something I haven't known before. So it's possible then that they may also have something that can viably scales for OLTP.
Yeah. So we're still exploring this, and more benchmarks are needed. Actually, I'm surprised how few and not comprehensive benchmarks there are published for this.
Yeah, what I know of Cytos is probably what you told me when we met. So it's about 5 years old.
Yeah.
Another big difference, and this is typically Nikolay's question, is on the license front. I think you've picked about as open a license as you could possibly pick, which is not the case, I think, for many of the other projects. So that feels to me like a very Supabase thing to do, and also in line with what Vitess did. And that seems to me like a major advantage in terms of collaborating with others, other providers also adopting this or working with you to make it better. Is what's your philosophy on that side of things?
My philosophy is my metric for success is adoption.
Yeah.
And the only way to have a project be adopted is to have a good license, a license that people are confident to use. That has been the case from day one of Vitess. We actually first launched with BSD license, which is even more permissive than Apache. And then when we moved the project to CNCF, they said, oh, no, we need Apache license, which is why we converted it to that one. So adoption has always been,
Why do they say it? Do you know?
Why
is it?
CNCF wants
Yeah.
Apache?
Yeah.
I think Apache is a pretty good license. They just made it a policy. I mean, had we
I
asked
see.
to keep the BSD license, they would have allowed us. But we didn't feel like it was a problem to move to Apache.
Yeah, and I remember you described like in when you did it in YouTube, you thought about external users. You need external users for this project to grow, right?
Yeah,
And I guess at Google, AGPL is not popular at all. We know it.
Oh, banned.
Banned.
Totally.
Yeah, and Citus is AGPL, which
Oh,
is
okay.
interesting. Yeah. Also, compared to Citus, I think like you have chances to be compatible with RDS and other managed Postgres, like to work on top of them, right? Unlike Citus, which requires extension and so on, right?
Correct. Yes. The one of like this was actually something that we learned very early on. Wanting to work, like we made a like 5-line change on MySQL just to make Vitess work initially, and it was such a nightmare to keep that binary up, to keep that build running,
Fork.
and to keep that fork alive. So we decided no, it's like we are going to make this work without a single line of code of change in MySQL. And that actually is what helped Vitess move forward, because people would come in with all kinds of configurations and say, make it work for this. So in this case, actually, we'll probably talk about the consensus part. That is one part that we think it is worth making a patch for Postgres, and we're going to work hard at getting that patch accepted. But I think what we will do is we will also make Multigres work for unpatched Postgres for those who want it that way. Except they will lose all the cool things about what consensus can give you.
I'm smiling because we have so many variations of Postgres these days. I would expect people coming not only with different configurations of Postgres, but also with various flavors like Aurora.
Plugins.
Or we have a client who just migrated from regular Postgres to AlloyDB. Hello from Google Cloud,
wow.
right? And they already sharded on application side. But imagine they could come to you and say, let's support AlloyDB now. It's almost Postgres, right? So yeah, so these things might happen as well. Like
don't they claim full compatibility with Postgres? I thought even
not
Aurora
full,
claimed
but most of it. It's they did interesting stuff in memory, like column storage in memory for tables. It's raw storage on disk, but column store in memory. So, but it looks like kind of Postgres, and we actually even had some questions answered from my team unexpectedly, because we don't normally work with AlloyDB, but it looks like Postgres. So I could imagine the request, let's support AlloyDB as well.
Yeah.
Anyway, but my question, like, I remember feature in Vitess that we work with RDS and managed MySQL. Did these features, like, has this feature survived?
No, actually, later we decided that at least we call it actually managed versus unmanaged. Managed means that Vitess manages its databases, and unmanaged means that the database is managed by somebody else. Vitess just acts as a proxy to serve queries. At some point of time, we realized that supporting both is diluting our efforts. And that's when we decided, okay, it's not worth it to try and make this work with every available version that exists out there in the world. And we said, okay, we will do only managed, which means that we will manage it ourselves. And if you want, we'll build the tools to migrate out of wherever you are. And we'll make it safe, we'll make it completely transparent. In other words, you deploy Vitess on both, and then we'll migrate your data out without you having to change your application. But then Vitess can be more intentional about its features, more opinionated about how clusters are to be managed. And we were able to commit to that because at that point, Vitess had become mature enough. People were completely trusting it. They actually preferred it over previous other managed solutions. So it wasn't a problem at that time.
Yeah, it's not a surprise. That's why I asked, because you talk about local disks, backups, HA, a lot of stuff, right? And
Yeah,
basically,
five nines is like what Vitess
yeah.
shoots for, and like most big companies that run Vitess do operate at that level of availability.
So what's the plan for Multigres? Going to support, so not only managed version, right?
Only so the it would be yes, it would be only managed versions because I believe that the cluster management section of Vitess will port directly over to Postgres, which means that you will
Yeah.
once it goes live, it will be coming with batteries included on cluster management, which should hopefully be equal to or better than what is already out there. So I don't see a reason why we should try to make it work with everything that exists today.
So it means there is no like this is the same like with Cytos. It doesn't work with RDS on one hand, but on another hand, I don't see it's only a sharding solution. It's everything, which is great. I mean, it's interesting, super interesting. So a lot of problems will be solved, and I expect even more managed services will be created. I don't know how it will continue, like in terms of Supabase, because of the very open license and so on. But also, I expect that many people will reconsider their opinion about managed. We had an episode about this. This is my usual opinion about managed services because they hide super user from you. They don't provide you access. It's hard to troubleshoot problems. In this case, if problems are solved in this, and this gives you a new way to run Postgres, so if many problems solved, it's great, right? If you want
Yeah,
to do self-managed, for example. Yeah.
Yeah, if you may not know, the initial focus of Vitess is actually solving these problems first. Sharding came much later, like protecting the database, making sure that they survive abusive queries. Basically, that's what we built Vitess for initially. And the counterpart of taking away power from the user, like you said, we now know exactly how to make sure that the cluster doesn't go down. And two, we countered that by building really, really good metrics. So when there is an outage, you can very quickly zero in on a query. If a query was responsible, Vitess will have it on the top of the line, saying that this is a query that's killing your database. So we built some really, really good metrics, and which should become available in Multigres, probably from day one.
That's interesting. I didn't see. Maybe I missed. I didn't see in README you are writing right now in the project.
There is a last section called observability.
Okay. I missed it. I need to revisit. We're actually building something there as well, like for regular Postgres. I'm very curious. I will definitely revisit this. Interesting. Okay. So yeah, great, and yeah.
Also,
Michael?
I feel like this is quite a big difference on at least with Cytus in terms of the philosophy, or at least the origin story. I feel like that started much more with OLAP focused features in terms of distributed queries and parallelized across multiple shards and aggregations and columnar and like loads of things that really benefit OLAP workloads. Whereas this has come from a philosophy of let's not worry about optimizing for those cross-shard queries. This is much more, let's optimize for the single shard, very, very short, quick OLTP queries, and let's make sure we protect it against abusive queries. So it feels like architecturally it's coming from a very different place of what to optimize for first.
And historically, that was YouTube's problem. Surviving the onslaught of a huge number of QPS and making sure that one single QPS doesn't take the rest of the site down.
Yeah, perfect. Makes loads of sense. So actually, before we move on too much from that, where do you see sharding as becoming necessary? Like, is it just a case of a total number of QPS or like writes per second type thing? We've talked about sharding in the past and talked about kind of a max that you can scale up to, perhaps in terms of writes, in terms of wall A wall per second, I think, was the metric we ended up discussing. Are there other reasons or kind of bottlenecks that you see people getting to that sharding then kind of makes sense as it's now time, or you should be considering it at this point?
Well, there is a physical limiting factor, which is the single, if you max out your single machine, that is your Postgres server, then that's the end of your scale. There is nothing more to do beyond that. And there are a lot of people already hitting those limits from what I hear. And the sad part of it is they probably don't realize it. As soon as that limit is hit, in order to protect the database, they actually push back on engineering features indirectly, saying that, this data, can you make it smaller? Can you somehow lower the QPS, or could you put it elsewhere? And
let's stop showing this number on front page and so on.
And it affects the entire organization. It's a very subtle change, but the entire organization slows down. Like we experienced that at YouTube when we were at our limits. The default answer from a DBA was always no. Mm-hmm. We used to even kid, no? The answer is no. What's your question? And when we started sharding, it took us a while to change our answer to say that, bring your data. No? Like we can scale as much as you want. Believe it or not, we went from 16 shards to 256 in no time. And the number of features in YouTube exploded during that time because there was just no restriction on how much data you wanted to put. And coming back here, the reaching the limit of a machine is actually something you should never do. It's very unhealthy for a large number of reasons. Like even if there is a crash, like how long is it going to take to recover? Like the thing that we found out is once you can shard, it actually makes sense to keep your instances way, way small. So we used to run like 20 to 50 instances of MySQLs per machine. And that was a lot healthier than running big ones for a couple of reasons. One is if you try to run so many threads within a process, that itself is a huge overhead for the machine. And it doesn't do that very efficiently, whereas it does it better if you run it as smaller instances, I think. It's more of a feeling, but I don't know if there is proof or whatever. But in like Go, for example, wouldn't do well. Go, I think, beyond a certain memory size or beyond a certain number of Go routines would start to slow down, would not be as efficient as it was before, mainly because the data structures to keep track of those threads and stuff, they are growing bigger, right? But more importantly, on an outage, a smaller number of users are affected. If you have 256 shards and one shard goes down, it is 1/256th of the outage, right? And so the site looks a lot healthier, behaves a lot healthier. There's less panic if a shard goes down. So people are, a lot less stressed managing such instances.
Right. I wanted to mention that this discussion was with Lev Kokot of pgdoc, yes, which is competitor as well, a new sharding tool written in Rust. And we discussed that there is a big limitation when Postgres... So replication, physical replication has limitation because it's single-threaded process on standby. If we reach somewhat 150, 200, 250 megabytes per second, depending on core and also number of, structure of tuples and so on. We hit one single CPU, 100%, one process, and it becomes bottleneck, and replica standbys, they start lagging. It's a big nightmare because you usually but that's at high scale you have multiple replicas and you offload a lot of read-only queries there. And then you don't know what to do except, as you described, let's remove this feature and slow down development. And this is not fun at all. So what I'm trying to do here is trying to move us to discussion of replication, not physical but logical. I noticed your plans involve heavily logical replication in Postgres, but we know it has it's improving every year. So like when we started the discussion 5-6 years ago, it was much worse. Right now it's much better. Many things are solved, improved, but many things still are not solved. For example, schema changes are not replicated, right? And sequences, there is work in progress, but if it's committed, it will be only in Postgres 19, not in 18. So it means like long wait for many people. So what are your plans here? Are you ready to deal with problems like this? In pure Postgres problems, you know?
Yeah. I if you ask me, I think the Postgres problems are less than what we faced with MySQL.
I wanted to involve physical as well, because this great talk by Kukushkin, which describes very bad anomalies when data loss happens and so on. Yeah, let's talk about this.
Yeah, we should talk about both. I think overall the Postgres design is cleaner, is what I would say. Like you can feel that from things. Like the design somewhat supersedes performance, which I think in my case is a good trade-off, especially for sharded solutions, because some of these design decisions affect you only if you are running at, if you are pushing it really, really hard, then these design decisions affect you. But if your instances are small to medium size, you won't even know. And then you benefit from the fact that these designs are good. So I actually like the approaches that Postgres has taken with respect to the wall as well as logical replication. And by the way, I think logical replication theoretically can do better things than what it does now, and we should push those limits. But yes, I think the issue about schema not being as part of logical replication, it feels like that is also a theoretically solvable problem, except that people haven't gotten to it. I think there are issues about the transactionality of DDLs, which doesn't even exist in MySQL. So at least in Postgres, it's like it exists in most cases. There are only a few cases where it is not. And for such things like a proxy layer like Multigres or Vitess, it's a no problem for them, because if you say, oh, okay, this particular construct is not transactionally safe, well, then we'll even prevent you from doing it transactionally, because we don't want you to get the wrong impression. We'll let you do it non-transactionally, and we know that it's non-transactional, and therefore we can do something about it, right? Those abilities don't exist previously. But eventually, if it becomes transactional, then we can actually include it in a transaction.
Yeah, just for those who are curious, because there is like concept all DDL in Postgres is transactional. Here we talk about things like create index concurrently, because we had discussion offline about this before recording. So yeah, create index concurrently it can be an issue, but you obviously have a solution for it. That's great.
The way I would say it is, we have dealt with much worse with MySQL. Okay. So this is much better than what was there then.
Sounds good.
Yeah.
Okay, good. And let's talk about physical replication, because I saw you are going to use it. So each shard is going to have standbys. And
correct.
With Quorum commit, right? So like we don't lose data, because data is on local disks by default, as I understand, like, and ephemeral in cloud. So we want to be sure data is written to at least 2 places, for example, or 3, right? Configurable, correct. Of course. Here, this interesting talk by Kukushkin, he presented it recently at an online conference by Microsoft, describing that like synchronous replication in Postgres is not what you think.
Correct.
So, right. What are you going to do about this?
Well, I was just chatting with someone, and essentially synchronous replication is theoretically impure when it comes to consensus. I think it's provable that if you use synchronous replication, then you will hit corner cases that you can't handle. And the most egregious situation is that it can lead to some level of definitely split brain, but in some cases it can even lead to downstream issues. Because it's a leaky abstraction, it's a leaky implementation, there are situations where you can see a transaction and think that it is committed, and later the system may fail and in the recovery may choose not to propagate that transaction, or may not be able to, and it's going to discard that transaction and move forward.
But this is same as with asynchronous replication. It's the same. We're just losing some data, right?
Exactly. Yeah. It is same as asynchronous replication. Yes.
It's not split brain. It's just data loss.
It's data loss. Correct. It's data loss.
Yeah.
But for example, if you are running like a logical replication off of one of those, then that logical replication may actually propagate it into an external system, and now you have corrupted downstream systems that don't match the source. So those risks exist, and at Vitess scale, people see this all the time, for example, and they have to build defenses against this, and it's very, very painful. It's not impossible, but it's very hard to reason about failures when a system is behaving like this. So that is the problem with synchronous replication, and this is the reason why I feel like it may be worth patching Postgres, because there is no existing primitive in Postgres on which you can build a clean consensus system. I feel like that primitive should be in Postgres.
I now remember from Kukushkin's talk, there is another case when on primary transaction looks like not committed because we wait a replica, but the replica somehow is like lost connection or something, and then we suddenly, and client thinks it's not committed because commit was not returned. But then it suddenly looks committed. It's like not data loss, it's data unloss somehow.
Correct.
Like suddenly. And this is not all right as well. And when you think about consensus, I think you are very like good describing these things like concept and distributed systems. It feels like if you have two places to write, definitely there will be corner cases where something will go off if you don't use two-phase commit, right?
Correct.
And here we have this. But when you say you are going to bring something with consensus, it immediately triggers my memory how difficult it is and how many attempts it was made to bring pure HA to Postgres, just to have auto failover. All of them failed. All of them. And they say, let's it be outside of Postgres. So here maybe it will be similar complexity to bring this to inside Postgres. Is it possible to build it outside this thing? Maybe
it is not possible to build it outside, because if it was, that is what I would have proposed. The reason is because building it outside is like putting Band-Aid over the problem. It will not solve the core problem. The core problem is you committed data in one place, and if that data can be lost, and there is a gap when the data can be read by someone, is the root cause of that problem. That is unsolvable. Even if you later Raft may choose to honor that transaction or not, and that becomes ambiguous. But we don't want ambiguity, right?
What if we created something, extension to commit, like make it extendable to talk to some external stuff to understand that commit can be finalized or something? I don't know, consensus.
Correct.
Yeah.
So essentially, if you reason through about this, your answer will become a two-phase system.
Yeah.
Without a two-phase system,
scares me.
You cannot.
But I as I told you, two-phase commit in OLTP world, in Postgres OLTP world, considered really, really slow, and the rule is let's just avoid it. I see your enthusiasm, and I think I couldn't find good benchmarks. Zero published.
This is not two-phase commit, by the way. This is two-phase synchronization.
I understand it's not in two-phase commit. It's like more communication happens. I understand this.
Yeah. So two-phase synchronization, the network overhead is exactly the same as full sync, because the transaction completes on the first sync. Later, it sends an acknowledgement saying that yes, I'm happy, you can commit it, but the transaction completes on the first sync, so it will be no worse than full sync.
Yeah, what compared to current situation when primary commit happens, but there is a lock which is being held until...
Correct. It is the same cost.
We wait until standby. And for user, it looks like when lock is released, it thinks, okay, commit happens. But the problem with this design, if, for example, standby restarts, lock is automatically released and commit is here and it's unexpected. This is the data unloss, right? So
Correct.
You are saying we can redesign this, network cost will be the same, but it will be pure. Yeah, that's great. I like this. I'm just thinking, will it be acceptable? Because bringing auto failover is not acceptable. There was another attempt last year from someone, and with great enthusiasm, let's bring auto failover inside Postgres. Actually, maybe you know this guy. It was Konstantin Osipov who built Tarantul database system. It's like in memory. He was ex-MySQL in performance. After Zaitsev. Zaitsev was ex-MySQL, then Osipov was MySQL. And so Konstantin came to Postgres saying, let's build this. Great enthusiasm, but it's extremely hard to convince such big thing to be in core. So if you say it's not big thing, this already...
So I can, I'll probably have to explain it in a bigger blog, but essentially, now that I've studied the problem well enough, the reason why it's hard to implement consensus in Postgres with the wall is because they are trying to make Raft work with wall, and there are limitations about how the Raft, how commits work within Postgres that mismatch with how Raft wants commits to be processed. And that mismatch, so far, I have not found a way to work around that. But a variation of Raft can be made to work.
Interesting.
The way I don't know if you know about my blog series that I wrote when I was at PlanetScale. It's an 8-part blog series about generalized consensus. People think that Raft is the only way to do consensus, but it is one of 1,000 ways to do consensus. So that blog series explains the rules you must follow if you have to build a consensus system. And if you follow those rules, you will get all the properties that are required by a consensus system. So this one that I have, the design that I have in mind, follows those rules, and I am able to prove to myself that it will work, but it's not Raft. It's going to be similar to Raft. I think we can make Raft also work, but that may require changes to the wall, which I don't want to do. So this system I want to implement without changes to the wall as possibly a plugin.
Yeah. Well, now I understand why another reason you cannot take Patroni, not only because it's Python versus Postgres, but also because you need another version of consensus algorithm.
Correct.
And among those 100,000 millions of ways.
By the way, Patroni can take this and use it because it's very close to how full sync works.
Good. Okay.
I was just thinking, watching Alexander Kukushkin's talk, he said a couple of things that were interesting. One is that he was surprised that this hasn't happened upstream. So you definitely have an ally in Kukushkin in terms of trying to get this upstreamed, but also that he thinks every cloud provider has had to patch Postgres in order to offer their own high availability products with Postgres. Each one has had to patch it, and they are having to. You mentioned earlier today how painful it is to maintain even a small patch on.
I don't think it's every. I think it's Microsoft for sure, knowing where Kukushkin works at.
Yeah,
but maybe more. Not every.
Yeah. All I mean is that there are a growing number of committers working for hyperscale and hosting providers. So I suspect you might have more optimism for consensus, or at least a few allies in terms of getting something committed upstream. So I personally think there might be growing chance of this happening, even if it hasn't in the past for some reason.
Yeah, I feel like also being new to the Postgres community, I am feeling a little shy about proposing this upfront. So what I am thinking of doing is at least show it working, show it working at scale. Have people gain confidence that this is actually efficient and performant and safe. So I also plan to, I don't know if you've heard of FlexPaxos, which is actually, in my opinion, a better way to handle durability, because today's cloud environments are a lot more complex. And a simple majority-based quorum is actually very hard to configure if your needs are different, which actually FlexPaxos does handle. It's actually something I'm a co-inventor of some sort. And this blog post...
Yeah. I only heard the name, that's it. So can you explain in a little bit, not super deep?
Oh, sure, yeah. So actually, let me explain what is the reason why. So FlexPaxos was published a few years ago, about 7 years ago or so. And you'll see my name mentioned there, which I feel very proud of. And the blog series that I wrote is actually a refinement of FlexPaxos. And that actually explains better why these things are important. The reason why it's important is because people think of consensus as either a bunch of nodes agreeing on a value, right? That's what you commonly hear. Or you think of reaching majority, reaching quorum is important. But the true reason for consensus is just durability. Is when you ask for a commit and the system says, yes, I have it, you don't want the system to lose it. So instead of defining quorum and all those things, define the problem as it is and solve it the way it was asked for is, how do you solve the problem of durability in a transactional system? And the simple answer to that is, make sure your data is elsewhere.
Yeah. I love how simple you make it.
Yeah, if you make sure your data is elsewhere, if there is a failure, your challenge is to find out where the data is and continue from where it went. And that is all that consensus is about. And then all you have to do is have rules to make sure that these properties are preserved. And Raft is only just one way to do this. So if you look at this problem, if you approach this problem this way, you could ask for something like, I just want my data to go across availability zones. As long as it's in a different availability zone, I'm happy, right? Or you can say, I want the data to be across regions, or I want at least 2 other nodes to have it, right? So that's your durability requirement. But you could say, I want 2 other nodes to have it, but I want to run 7 nodes in the system or 20 nodes. It sounds outrageous, but it is actually very practical. In YouTube, we had 70 replicas, but only one node, the data have to be in one other node for it to be durable, and we were able to run this at scale. The trade-off is that when you do a failover, you have a wild goose chase looking for the transaction that went elsewhere, but you find it and then you continue. And so that is basically the principle of this consensus system. And that's what I want to bring in Multigres, while making sure that the people that want simpler majority-based quorums to also work using those same primitives.
Just quickly to clarify, when you say the wild goose chase, is that because it was one of 70, but different transactions could have gone to different of the 70, or it's always the same one, but you have to know which one that is?
No, it could be any one. The way we ran it, the way we ran it, it is one. It could not be at any given point of time. There is only one primary, which means that there is only one transaction that you have to chase down.
The latest one.
The latest one, yes.
Yeah, makes sense.
Yeah. There was a time when we found that transaction in a different country. So we had to bring it back home and then continue. There was once it happened in whatever the 10 years that we ran.
It's interesting that talking about sharding, we need to discuss these things, which are not sharding per se, right? So it's about HA inside each shard, right?
It's actually like what I would call healthy database principles, which is, I think, somewhat more important than sharding.
Yeah.
It is true that it is to do with it being a distributed system, right? And that is because it's sharded, no?
I think they are orthogonal.
Okay.
Yeah, I think sharding, like you can do sharding on anything, right? Like you can do sharding on RDS. Somebody asked me what about Neon? I said you can do sharding on Neon too. It's like you put a proxy in front and then it does the sharding. But the problem with sharding is it is not just a proxy. That's what people think of it when they first think of the problem because they haven't looked ahead. Once you have sharded, you have to evolve. You start with 4 shards, then you have to go to 8 shards. And the evolution is not linear this way. Actually, it's an exponential growth because 4, 8, 16. But at some point of time, it changes because your sharding scheme itself will not scale. Like if you, for example, are in a multi-tenant workload and you say shard by tenant, at some point of time, a single tenant is going to be so big that they won't fit in an instance. And that we have seen. And at that time, you have to change the sharding scheme. So how do you change the sharding scheme? Slack had to go through this, where they were a tenant-based sharding scheme, and a single tenant just became too big. They couldn't even fit one tenant in one shard. So they had to change their sharding scheme to be user-based. They actually talk about it in one of their presentations. And Vitess has the tools to do these changes without actually you incurring any kind of downtime, which again, Multigres will have. I keep talking about Vitess, but these are all things that Multigres will have, which means that you are future-proofed when it comes to, and these are extremely difficult problems to solve. Because when you're talking about changing the sharding scheme, you are basically looking at a full crisscross replication of data.
Mm-hmm.
And across data centers.
Yeah, and also, I know Vitess version 3, right? It was when you changed, basically created a new planner, right? To deal with arbitrary query and understand how to route it properly and where to execute it. Which is it a single shard or it's global or it's like different shards and so on? Like, are you going to do the same with Postgres? I think yes, right?
So that's the part that I'm still on the fence. That, by the way, the V3 now has become Gen 4. It's actually much better than what it was when I built it. There is the problem with V3 is that it is still not a full query. It doesn't support the full query set yet. It supports like 90% of it, I would say, but not everything. On the temptation side, there's the Postgres engine that supports everything. So I'm still debating how do we bring the two together. If it was possible to do a simple git merge, I would do it. But obviously this one is in C, this was in Go. And the part that I'm trying to figure out is how much of the sharding bias exists in the current engine in Vitess. If we brought the Postgres engine as is, without that sharding bias, would this engine work well for a sharded system?
So it's this looks like Cytos already, right? If you bring a whole Postgres, there's a library libpg query by Lucas Fittel, which is basically takes the parser part of Postgres and brings it to, and there is a Go version of it as well, right? So on top
libpg query, you said?
Yeah. I will send it to you. So and many systems use it when we need to parse. One day I told it to SPQR guys about this and eventually I think they ended up using it. I think Lev uses it. pgdoc also uses the Rust version.
Is it like 100% Postgres compatible?
Well, it's Postgres source. It's based on Postgres source code. So Parser is fully broad, but it's not whole Postgres. So maybe you should consider this, right? If thinking about parsing, I mean queries and so on. But I'm very curious. I also noticed you mentioned routing, like read-only queries routed to replicas automatically, and this concerns me a lot because Many Postgres developers, who use it, users, they use PL/PGSQL functions, all Python functions, anything, which are writing data. And the standard way to call function is select function name. So understanding that this function is actually writing data is not trivial, right? And we know in PGPool, which all my life I just avoid. I touched it a few times, decided not to use at all because it tries to do a lot of stuff at once, and always considered like, no, I'm not going to use this tool. So PGPool solves it like saying, okay, like let's build a list of functions which are actually writing or something like this. So it's like patch approach, workaround approach. So this is going to be a huge challenge, I think, if you for automatic routing, it's a huge challenge.
Yeah, I think this is the reason why I think it is important to have the full Postgres functional engine in Multigres, because then these things will work as intended, is my hope. What we will have to do is add our own sharded understanding to these functions and figure out, what does it mean to call this function, right? If this function is going to call out to a different shard, then that interpretation has to happen at the higher level. But if that function is going to be accessing something within shard, then push the whole thing down and just push the whole select along with the function down and let the individual Postgres instance do it.
Yeah, but how to understand? Function can contain another function and so on. Like it can be so complex in some cases.
Yeah.
It's also funny that there is actually Google Cloud SQL supports it, like kind of language. It's not language, called PL proxy, which is sharding for those who have workload only in functions. This can route to proper shard. It was created at Skype. It still exists, but not super popular these days. But there is a big requirement to write everything in functions. In your case, if you continue like, I would expect in some cases you would say, okay, don't use functions. But I'm afraid it's not possible. Like I love functions. Actually, Supabase loves functions because they use Postgres, right? Postgres, like, it provokes you to use functions.
Oh, really? So yeah. Actually, I saw that. Yeah. So in Vitess, I feel like this was a mistake that we made, which is if we felt that any functionality that you used didn't make sense. Like if I were you, I wouldn't do this, right? Because it won't scale. It's a bad idea. It's like those we didn't support. We didn't want to support. We said, no, we will never do this for you because we'll not give you a rope long enough to hang yourself. Basically, that was our philosophy. But in the new, in Multigres, we want to move away from that, which means that if you want to call a function that writes, have at it.
Just put a comment. It's going to write something.
Yeah, if you want a function that calls a function that writes, have at it. If we cannot, like the worst case scenario for us is we don't know how to optimize this, and what we will do is we'll execute the whole thing on the VT-gate side.
Mm-hmm. There's another. I remember there is interesting solution in AWS RDS proxy, which as I know it, maybe I'm wrong, when they needed to create a global, it's called, I think, Aurora global database maybe, or something like this. So there is a secondary cluster living in a different region, and it's purely read-only, but it accepts writes. And when write comes, this proxy routes it to original primary, waits until this write is propagated back to replica and responds.
Oh wow!
Yeah,
I don't think that feature. I don't know how even that feature can be supported.
No, it's just some exotic, interesting solution I just wanted to share. Maybe if we, for example, if you originally route a write to a replica, then somehow in Postgres you understand, it's actually a write.
Okay. Yeah, so maybe 100% is theoretically impossible to support.
Yeah, it's okay. It's super exotic. Okay.
Yeah.
Okay.
But I think if people are doing like that, doing things like that, it means that they are trying to solve a problem that doesn't have a good existing solution.
Exactly.
Right. So
Hard
if we can
problems.
find a good existing solution, I think they'll be very happy to adopt that instead of whatever they were trying to do.
Well, this is just multi-region setup. When I saw not one CTO which wanted it for dealing with Postgres, say we are still single region. We need to be present in multiple regions in case if one AWS region is down. Right. It's also about the yeah. So availability and the business characteristics. So yeah. Anyway. Okay. Yeah, it's exotic, but interesting still. Yeah.
So you've got a lot of work ahead of you, Sugu.
I feel like we barely covered one of so many topics.
Yeah. Let's touch something else. Maybe it's a very long episode, but it's worth it. I think it's super interesting. What else? What else?
I think the other interesting one would be 2PC and isolation.
Isolation from what?
The one issue with the sharded solution is that, again, this is a philosophy. For the longest time in Vitess, we didn't allow 2PC. We said you shard it in such a way that you do not have distributed transactions. And many people lived with that, and some people actually didn't
let me
adopt
interrupt. Let me interrupt you here because this is the most the best feature I liked about Vitess. It's this materialized feature when data is brought.
Oh yeah, materialized is another. That's actually a better topic than 2PC.
well, yeah, because this is your strength, right? So this is I love this idea. Basically, a distributed materialized view which is incrementally updated.
Yes,
right?
yes.
That's great. We need it in Postgres ecosystem.
Correct.
Just maybe as a separate project even. We lack it everywhere. So yeah, this is how you avoid distributed transactions, basically, right?
No, this is one way to avoid it.
One way.
There are two use cases where materialized views are super awesome. A table that has multiple foreign keys, that has foreign keys to two different tables is the classic use case, where the example I gave was a user that's producing music and listeners that are listening to it, which means that the row where I listen to this music has two foreign keys, one to the creator and one to the listener. And where should this row live? Right? Should this row live with the creator or should this row live with the listener is a classic problem. And there is no perfect solution for it. It depends on your traffic pattern. But what if the traffic pattern is one way in one case and another way in another case? There is no perfect solution. So this is where in Multigres what you could do is you say, okay, in most cases, this row should live with the creator. Let's assume that, right? So then you say this row lives with the creator and we shard it this way, which means that if you join the creator table with this event row, it'll be all local joins. But if you join the listeners table with this event row, it's a huge cross-shard wild goose chase. So in this case, you can say, materialize this table using a different foreign key, which is the listener's foreign key, into the same sharded database as a different table name. And now you can do a local join with the listener and this event table. And this materialized view is near real time, basically the time it takes to read the wall and apply it. And this can go on forever. And this is actually also the secret behind resharding, changing the sharding key. This is essentially a table that has real time present with two sharding keys. If you say, at some point of time, this is more authoritative, all you have to do is swap this out. Make one the source, the other as a target. You change your sharding key. Actually, the change sharding key works exactly like this for a table.
Distributed denormalization technique. This is what it is.
Yeah, exactly. And the other use case is when you reshard, you leave behind smaller tables, reference tables, we call them. And they have to live in a different database because they are too small. And even if you shard them, they won't shard well. Like if you have, a billion rows in one table and, 1,000 rows in a smaller table, you don't want to shard your 1,000-row table. And there is no benefit to sharding that either. So it's better that row lives, that table lives in a separate database. But if you want to join between these two, how do you do it, right? The only way you join is join at the application level, read one and then read the other. And so at high QPS, it's not efficient. So what we can do is actually materialize this table on all the shards as reference tables. And then all joins become local.
Yeah. And you definitely need logical replication for all this. So this is where we started, like challenges with logical replication.
Yeah,
right?
Yeah.
Great.
You do have so the reason why 2PC is still important, because there are trade-offs to this solution, which is there's a lag. So it takes time for the things to go through the WAL and come to the other side. Whereas 2PC is essentially basically the transaction system itself trying to complete a transaction, which means that it will handle cases where there are race conditions, right? If somebody else tries to change that row elsewhere while this row is being changed, 2PC will block that from happening. Whereas in the other case, you cannot do that.
Yeah, if it's just user views of some video like on YouTube, we can say okay, there will be some lag, probably some small mistake, it's fine. But if it's financial data, it should be 2PC. But latency of write will be high, throughput will be low, right? This is.
I actually want to I read the design of, which is again, by the way, very elegant API, and I assume I can see the implementation on the API. And I don't think we will see performance problems with 2PC.
We need to benchmark it.
We will benchmark it, but I will be very surprised. I think there are some isolation issues that we may not have time to go through today because it's a long topic. Like the way 2PC is currently supported in Postgres, I think it'll perform really well.
Isolation issues when we sit in read committed and use 2PC. You mean this, right? Not unrepeatable in default.
Yeah, read committed, I think there will be some trade-offs on read committed, but not the kind that will affect most applications. MVCC will be the bigger challenge. But from what I hear is most people don't use, the most common use case is read committed.
Of course, it's default. Yeah, it's faster.
It's the default. Yeah. So people won't even. I think this.
Oh, they're already on some. Yeah. They're already in bad state. It won't be worse.
It won't be worse. Yes.
Yeah.
Yes. Yeah.
As for 2PC, it of course depends on the distance between nodes, right? A lot. Like if they are far, they need to. We need to talk, like client is somewhere, two nodes are somewhere, and if it's different availability zones, it depends, right? So this distance is big contributor to latency, right? Network, because there are four communication messages that are needed. So
correct. Actually, you can. I have actually the mathematics for it, but you're probably right. It's about double the number of round trips.
If we put everything in one AZ, client and both primaries, we are fine. But it's,
correct.
In reality, if they will be in different places, and if it's different regions, it's nightmare, of course. But at least
the 2PC is not done by the client, by the way. The 2PC would be done by the VT gate, which would be it should have the nodes nearby.
Should have in one availability
zone? Unless you did some crazy configuration. They should be pretty close to each other.
Pretty close means still different availability zones in general case, right?
No. The availability zone is only for durability.
Okay.
For replica level. But 2PC, you're coordinating between two primaries, which may actually be on the same machine for all you care. It's not.
Well, imagine a real practical case. We have sharded schema. We have every shard has primary and a couple of standbys, right?
Correct.
So, are you saying that we need to keep primaries all in the same availability zone?
That's usually how things are.
Interesting. I didn't know about this. By the way, I wanted to rattle a little bit about plain scale benchmarks they published last week. They compare to everyone. I wanted just, it's not like, I'm sorry, I will take a little bit of time. They compare to everyone, and they just published like plain scale versus something. And this very topic, they, on charts, we have plain scale in single AZ, everything, client and server in the same AZ. And line, which is like normal case, client is in different AZ. And line with same AZ is active, line is normal, not active. And others like Neon, Supabase, everyone, it's different. And of course, plain scale looks really well because by default they presented numbers for the same availability zone. And below, like the chart, everything is explained, but who reads it, right? So people just see the graphs. And you can select proper planet scale numbers and see that they are similar. But by default, the same as that number is chosen. And this is like benchmarking, you know, like.
Well, I think if you look at the architecture, like even fair comparison, planet scale should come out ahead. Like the performance of a local disk,
of course,
should.
Yeah. But this was select one. Disks don't matter. Disks
but
don't
select
matter.
one is not a benchmark. What?
Well, it was part of benchmark. It's just checking query path, but it fully depends on where client and server are located. So what's the point showing better numbers just putting client closer, right? It's like I don't like that part of that benchmark.
Oh, okay. So, I saw the publications, but I didn't go into the details because I thought, well, it has to be faster because it's on local disk. So
for data which is not fully in cache, of course, local disks are amazing versus ABS volumes.
You're right. Yeah, if the data is in cache, then there is then all the performance of everything would be the same.
Yeah, well, I wanted to share this. I was annoyed about this small trick, but I fully support the idea of local disks. It's great. I think we need to use them more in more systems.
I think I wouldn't be surprised if you reached out to Planet Scale. They may be willing to like if you want to run your benchmarks, they may be willing to give you the...
Yeah, there is source code published, and in general, benchmarks look great. The idea is great.
Okay.
And actually, with local disks, the only concern is usually the limit, hard limit. We cannot have more space. But if we have sharded solution, there is no such limit. Right? So
correct. But like speaking about the hard limit, right? Today's SSDs, you can buy 100 plus terabytes size SSD. Single SSD, and you can probably stack them up on one next to the other. And,
but in cloud there are limitations. For instances.
Okay, yeah. I saw AWS SSD over 100 terabytes.
In Google Cloud, 72 terabytes is hard limit for Z3 metal. And I didn't see more. So 72 terabytes, it's a lot, but sometimes it's already not a lot.
At that limit, your storage is not the limit. It's you will not be able to run a database of that size on a single machine.
Why not?
You will max out your CPU.
We have cases, CPU. Well, again, the problem will be replication. If we talk about single node, we can have
replication.
360 cores in AWS, almost 1,000 cores already for Xeon Scalable Generation 5 or something. So hundreds of cores, right?
Oh, okay.
The problem is Postgres design. If physical replication was multi-threaded, we could scale more.
Yeah.
So,
by the way, replication is not the only problem. Backup recovery. If your machine goes down, you're down for hours. Recovering something of that size.
Yeah. Not many hours. Someone in my team recently saw 17 or 19 terabytes per hour for recovery with PGP
Wow.
test or Volg. Yes, in AWS. I was like, my jaw dropped. On our podcast, I usually say 1 terabyte
Can you
is
repeat that? 17 or 19
17
terabytes per
terabytes
hour?
per hour. 17
Wow.
terabytes per hour with local disks. So this is important. With ABS, it's not
It's
possible.
good to know.
Yeah, well, right. Like with Michael, I was always saying 1 terabyte is like what you should achieve. If it's below, it's bad. Now I'm thinking 1 terabyte is
yeah.
already. Yeah. So with ABS volumes, we managed to achieve, I think, 7 terabytes per hour to restore with VolG, and that's
But
great.
there's a danger there. You could become a noisy neighbor. So we actually built throttling in our restore
Of course.
just to prevent noisy neighbors.
With local disks, you lose the ability to use ABS snapshots, cloud disk snapshots.
Correct.
That's what you lose, unfortunately. And they're great, and people enjoy them more and more. But yeah, so I agree. And for, as I remember, for 17 terabytes, it was 128 threads of VolG or PGP request. I don't remember.
Wow.
But with local disks, S3.
I need to
S3
update
great.
my. Now this technology is changing too fast.
Exactly. Yeah. Hundreds, of course, terabytes of RAM already, right? Like. Yeah.
Yeah.
But it does go straight to your point of the smaller they are, the faster you can recover still. And yeah,
you don't
that
hit
still
some
makes
of these limits. Like these systems were not designed with these types of limits in mind.
Yeah.
Some weird data structure, suddenly the limit of this is only 100 items, or and you hit those limit and then you're stuck. Like recently, Metronome had an issue. They had that outage,
multi-exact.
the multi-exact thing, which nobody has ever run before, but they hit that problem.
Yeah, we saw many problems also when you on the edge, and it pushes forward Postgres actually sometimes, but if you want to be on the safe side, but I really like it's kind of resilience characteristics when even if it's down, it's only a small part of your system is down. That's great.
Correct.
That's mature architecture already. When it's not,
that actually makes it easier to achieve 5 nines uptime.
Yeah.
because
that's the way you calculate. Like if only one node is down, you divide it by the number of users being
budget,
affected.
downtime
Yeah,
budget. Yeah.
budget, yeah.
That's great. Cool. I think it's maybe one of the longest episodes we had. Enjoyed it.
Oh my God, that's a long one.
I enjoyed it. I hope we will continue discussion of issues with logical, for example, and so on, and maybe if things will be improved and so on. Looking forward to test POC once you have it. Thank you so much
I'm so
for coming.
excited. Yes.
Yeah, thank you.
Yeah.
Thank
Is there
you.
any last things you wanted to add or anything you wanted help from people on?
I would say it feels like nothing is happening on the repository except me pushing, a few things changes, but a huge amount of work is happening in the background. Like some of these design work about consensus are all like almost ready to go. And there's also hiring going on. There are people coming on board very soon. So you will see this snowball. It's a very tiny snowball right now, but it's going to get very big as momentum builds up. So pretty excited about that. We may still have 1 or 2 spots open to add to the team, but it's filling up fast. So if any of you are very familiar, this is a very high bar to contribute to Multigres. You have to understand consensus, you have to understand query processing. But if there are people who want to contribute, we are still looking for maybe 1 or 2 people, and also on the orchestration side, on the Kubernetes side of things. Yeah, so that's...
Do you mind a small joke in the end, just not to finish on
I
serious
do not
note?
mind at all. Let's hear it.
Yeah, so I know what you're doing. You're writing a lot of Markdown right now, and then you will feed it to AI. And just
I wish.
okay.
Oh my God. I almost hope that day never comes, but It is so fun working on this project, creating it. Why do I want to give it to an AI to do it,
Okay. Good, thank you.
Well,
Enjoy it a lot. Yeah.
Yeah, thank you so much for joining us. It's great to have you as part of the Postgres community now, and I'm excited to see what you get up to.
And me too.
Thank you.
Wonderful. Thanks so much.
Thank you.
Bye-bye.